Okay, let's see today's POTD. So it's 2762 continuous subarrays. So in this question, you are given an array nums and you want to find out the number of continuous subarrays in the array nums. Okay, so what is continuous according to the definition? So uh, the subarray is continuous if and only if every pair of elements in that, if we do the absolute difference of them, that should be less than equal to 2. Okay, what does that mean? So let's take this example. So here, if we take like this as an subarray, okay, so in this, how many pairs are there? Only one pair can be found, which is 5 comma 4. So if we do the difference of that, then we will get obviously one which is less than 2, less than equal to 2. So therefore this is an continuous subarray. Now let's take this subarray. So how many pairs are there? So there can be like many pairs formed. So that would be 5 comma 4, then 5 comma, sorry, 5 comma 2, and yeah, 4 comma 2. Three pairs will be formed. And if we like take the difference, now 5 comma 4, yeah, the difference is 1, which is less than equal to 2. 4 comma 2 difference is 3, which is not less than equal to 2, and 4 comma 2 difference is 2, which is less than equal to 2. So in this subarray, if we take this as subarray, we get 3 pairs, but one of the pair is not satisfying the condition. So the difference is greater than equal to 2. So therefore we can't say this as a continuous subarray. Okay, so now we have to find out the number of continuous subarrays in a particular array. Okay, yeah. So what would be the approach of this question is, like, there is an observation, like for a subarray to be continuous, like there is one condition we can like observe, that the difference between the maximum and the minimum element of that subarray should be less than equal to 2. Obviously if those elements will have the difference less than equal to 2, obviously the numbers which are between them, obviously because we are targeting the range. So let's take this as an example. Okay, so the maximum element here, this subarray as an example. So maximum element here is 4, and smallest element is 2. So the range is 2 to 4. Now obviously this difference of this is less than equal to 2, and all the elements which are between this will uh, obviously the difference between them will be also less than equal to 2. So every pair will then form the difference less than equal to 2 only. Okay, we can take any example, like if let's suppose the range is 6 and 8. So the subarray, if the range is 6 and 8, so that means that the maximum element in that subarray is 8 and the minimum is 6. Now every element in that subarray will be between 6 and 8 only, and therefore all the pairs will satisfy this condition, which is less than equal to 2 difference. But if there is an subarray whose like difference is like smallest element is 2 and largest element is 5, which we saw in this case, then the difference is already here greater than equal to 2. Therefore that subarray cannot be a continuous subarray. Okay, so we get to know this, that from this, that we have to track the smallest and largest element in the subarray. Okay, that we have to track, and if it is less than equal to 2, then that like subarray will form, like, will be in our answer. Okay, but uh, is that like only that subarray will be in our answer? No, there will be many subarrays in that answer. So let's take an example. So let's suppose our subarray is 2 uh, 4 3 5, not 5, uh, 2 3 4. Okay, and yeah, yeah, this is a subarray. So now max element, min element is how much? Which is 2. Okay, max element is how much? Which is 4. Now difference between min and max, difference is how much? This is less than equal to 2. Okay, obviously difference between 4 and 2 is less than equal to 2. So the range is from 2 to 4. Obviously we can see all the elements are in between 2 to 4. So this is a continuous subarray. Okay, but uh, there can be many subarrays inside this also, which will be continuous, like this 3 comma 2 comma 3. Okay, this will also this is also a continuous subarray, because the minimum element is 2 and the largest element is 3, and yeah, it is satisfying the condition. So like if we get a window, okay, or we get a subarray which is having like the uh, which is a continuous subarray, then all the subarrays of that subarray will also be in our answer. Okay, so this is of length how much? So if you can take any subarray like 2 is a subarray, that is also a continuous subarray here. 4 comma 3 is also continuous subarray. You can check like min and max by applying that condition. 3 comma 2 comma 3 comma 4 is also subarray. Yes, so all the subarrays of this subarray will also be our be in our answer. Okay, so if the length, this length is how much? 6. Okay, so uh, length is equal to 6. So how much subarrays a 6 length array forms, subarray forms? That is 6 multiplied by, okay, okay, so it is like let's yes, so for 6 length subarray, the formula will be n into n plus 1 divided by 2. So we will get 6 into 6 plus 1 divided by 2. Okay, so these many subarrays we will get. So we will just add that to in our answer. Okay, yeah. Now the problem, one more problem is like this is solved. Like if we have to find the largest window, we can do that in sliding window. We will find the largest window, and which will satisfy this min max condition, like which will satisfy the all the elements are less than equal to 2, and then we will find all the subarrays of that, and we will add it to in our answer. But to keep track of this max and min element in the sliding window, we need to use a good data structure, and so therefore we will use tree map here. Actually there can be many solution of this problem. Okay, and you can like just uh, observe that by seeing the topics of this question. So there are many topics, so like you can, there can be many approaches, but I have used a tree map approach. So tree map is a data structure which is like stores the elements of the store the keys in an order. Okay, so in ascending order by default. So the first element of the tree map is the lowest, and the last element of the tree map is the largest. So obviously we will then keep track the minimum element as the if we will put all the elements of a subarray in the tree map. Okay, the minimum element will be at the first position, and the maximum element will be at the last position. Actually let's try to do it. So first, for sliding window, I will initialize two variables. Okay, and then I will take a data structure tree map integer comma integer. Okay, map is equal to new tree map. Okay, now while j is less than nums dot length. Okay, nums dot length. Okay, so j is less than nums dot length. Now first of all I will add that current element in the tree map. Okay, so map dot put nums of j. uh, okay, so map dot there can be a chance that like now if we in this case we put 4, and when we are putting another again a 4, so there can be an count of like there can be element 4 before in also before also in the map, so we will just include the count of it. Therefore we are taking a map default uh, nums of j 0 plus, yeah, so we have inserted the current element in the map. Now we will find the minimum and maximum first. Okay, in the map or in the subarray we can say. So yeah, map dot entry integer comma integer. Okay, so the smallest element will be map dot uh, let me do this, map dot first entry. So this is the smallest entry. Okay, so this is the smallest element in the map, and likewise the largest element, will be the last entry. Okay, the tree map is sorted in the ascending order. Now if like the small, okay, small, okay, sorry, large, minus small, large dot get key. Actually this is the entry, whole entry, like it will give you the pair, like key value pair. So you will get the key minus small dot get key, this is greater than 2. Okay, In case if it is less than equal to, then we are like finding the maximum subarray now. So like if we are reached till here 2 comma 4 comma 3, so the like the difference between the largest and smallest element is less than equal to 2. So this is not the maximum range till now we have got. So we will take for the next element, and then we will take for the next element until we get, until we come to here. And let's suppose here the 5 would had been there, then we will stop here, as we got the 5 and the minimum element is 2 and maximum element is now 5. Therefore this condition will arrive. Okay, yeah, until it is not it is not arrived, we will just do j plus plus. We have to maximize the range, and then at last obviously we will do this, add all the surveys in the answer. Okay, yeah, so if now this is the case, so now what we'll do, now what we'll do, as we have got this case, therefore now we have to we know that the uh, answer we have to, like, we got the maximum subarray which is satisfying the condition. Okay, and now no more maximum can be satisfied. Okay, we have to like now shift the I only, then only we get we can get that. So what we'll do, first we will increase the answer by adding the subarrays which is contributed by the current subarray. So the length of the current subarray would be int l is equal to, actually let's take it long, long l is equal to j minus I. So this will be the length. So let's suppose 0 was the starting index I, and we reached here. Okay, so 0 1 2 3 4 5 6 6 6 minus 0 is how much? 6. Yeah, so the length of the valid subarray was 6 only. Okay, yeah, so we got the length. Now we will do what, we will increase the answer by applying that formula which we have applied here. So we will increase the answer by the number of all subarrays possible. Okay, in that, from the largest subarray. So that will be L into L plus 1 divided by 2. Okay, yes. So we added that in our answer. Now what we'll do, we will now we have to increment the I. Okay, so this is our subarray now. Okay, and this is not satisfying the condition min max thing, the difference is greater than 2. So now we will increase the I until our condition is satisfied. Okay, so we will increase it. So while uh, this condition happens, just do what, first of all remove that element from that map. So uh, first of all decrement that element, map dot uh, put nums of I. So I have to remove nums of I from the subarray, so I will remove it from the map, nums of I, map dot get nums of I. So I will decrement the count of it. Okay, yeah, I have decremented it. Now if in case map dot get of nums of I, this is equal to 0, so the count becomes 0. So we will remove that element simply from the map, because we don't want it as in first entry or last entry which is tracking a max or min. So map dot remove nums of I, we have removed it. Now what we'll do, we will do the same thing here, update the small and large. Okay, and just we will do I plus plus. So this loop will run, and then we will again reach to a condition which is satisfying now our subarray. Okay, like subarray thing. So let's suppose we started from I. Okay, s is equal to I, like from an I1, and uh, our loop ran till I2. Okay, and which is less than, both are less than j. So now the problem is like you can see in this case, like 5424. Okay, 5424. So in this test case 5 comma 4. Okay, we got three subarrays from this. Okay, this is a valid subarray, and we got three subarrays from it. So from first we got three subarrays in which include 4. Okay, 4 as a subarray. This subarray they have included. Now again we will run our tape rule, like we will decrement the I, sorry, increment the I, and we will get this as an subarray. Okay, 4, 2 and 4, and from this we will get how much? We will get 6 subarrays. Okay, 6 subarrays, obviously, because the length of this is 3. Okay, and the length of this was 2, therefore we got 3 subarrays. Length of this is 3, both are valid, and therefore we got 6 subarrays. But this will also include 4. Okay, so 4 2 comma 4 will also include this 4 things, 4 subarray. Okay, and 5 comma 4 will also include this 4 subarray. So there are some overlapping like things which we have included in our answer. Okay, first of all let me declare the answer. So there are some overlapping, like we have added more things, like we have added 4 2 times. Okay, so there can be many elements in there, like there can be many 4 or many 2 like this here. Okay, so like yeah, so we this is now our subarray. Okay, and like we have included all the elements in that answer, but now this again, this will be our subarray, and we will include this is all this also in answer, but then this thing will get overlap now. uh, yeah, this thing, so we have to subtract that from the subarray. So this length, how can we get we subtract this from the answer? How can we get this? The length will be j, simply j minus I, because j will be here, and I, like after running the while loop, we will get that length. Okay, so we'll just update the length. J minus I is the length, and we will do the same thing. We will subtract those subarrays, overlapping subarrays, from the answer. Yes, yeah, so they will do this, and at the last, like if there is a case. Okay, imagine this is a case, like uh, the case is 1 comma 2 comma 3. Okay, so now all the elements are satisfying the subarray. All the elements are satisfying as a continuous subarray condition. Now this condition will never get reached. Okay, if voila thing, so we will, our answer will not update it, but we have to update it now. So at last what we'll do, at last we will if we will see condition, if this, okay, this thing, this is less than equal to 2, which is in this case we have included all the elements in the map, and the largest element 3 minus the smallest element 1, this is less than equal to 2. So what we'll do, we will just update our answer here. Okay, we'll update our answer here again, so by this formula. At last, yeah, and at last we will return the answer. And here actually large will not come, because that is a local variable inside the while loop. Therefore instead we will like map dot last entry, and here it will be map dot first entry. Okay, yes, so let's try to run this. Okay, so yeah, I have done this silly mistake. Okay, now it is running fine. Yeah, all things are getting accepted. Let's try to submit it. Yes, it's getting accepted. Okay, okay then, thank you all for watching.